Hello, in this video we're going to talk about the basics of functions. I got two graphs here. In this graph, y is defined as a function of x. In this graph, y is not defined as a function of x. And from here on out I'll just say y is a function of x. The reason, definition for y to be a function of x, for every x value there can be at most only one y value. So at this x value right here, you can see there is one corresponding y value. But in this graph right here, and let's say this x value, let's say this is x equal to 1, this is also x equal to 1, there are two corresponding y values. So in this graph, yes, y is a function of x. In this graph, no, y is not a function of x. And you can do what's called the vertical line test. Vertical line test is you just draw vertical lines to the graph. And as long as every time you draw a vertical line, you hit it most only once, it passes the test. Every time I hit it once, etc. But here I'll draw a vertical line right here. Psht. 1, 2, it failed. It failed. Y is not a function of x. If I drew it over here, you would see it failed again. It only has to fail once. But if you draw a vertical line through the graph, and it only hits once, at most once, at every location, y is a function of x. Alright, now we're going to do the same thing with equations. When we look at an equation and determine if y is defined as a function of x. So I'll put a couple equations up here. How about y plus x squared equals 25. I'll put y cubed plus x squared equals 25. I'll put y equals the square root of x minus 4, and I'll put y equal the absolute value of x plus 5. In all these four equations, y is defined as a function of x. Here, 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 here. The reason is, don't focus on the x. Focus on the y. The exponent of y, every time, look, the exponent here was y of 1. The exponent here was the first power, right here, first power. Yeah, and here was the third power. As long as it's not y to the second power, which is an even value, y will be defined as a function of x. So all these yes, all four of them. But down here, let's say we have y squared plus x squared equal to 4. And in this case, yes, absolutely, right here, this is the reason no. This is the reason no, y is not defined as a function of x. Alright, so yeah, pretty simple. Just look where the y is and look at the exponent. If it's a 2, or if it's even, it could be y to the 4th, alright? The answer is going to be no, y is not defined as a function of x. And all these, you can have x cubes, x squareds, x to the 4th, square roots of x's, but as long as that exponent of a y is an odd value, y to the 1st, even y cubed, it's good to go. Y is defined as a function of x. And in a future topic later on, this equation right here, y squared plus x squared equals 4, that's actually a circle. Everyone a circle? If this is, here, I'll write it this way, x squared plus y squared equal to 4. Boom! No, y is not defined as a function of x, and as you can tell, it fails the vertical line test. Alright, now we're going to talk about this graph over here to the right. Alright, this graph here, as you can tell, y is a function of x. It passes the vertical line test. We're going to talk about things like domain and range, etc. So I'm going to start with domain. Alright, we're going to find, everyone, the domain of this function. The domain describes the x values, all the x values taken on by this function, which is a lot of x values. We're going to describe this in interval notation. Okay? And look, at x equal to -3, this graph exists. At x equal to -2, this graph exists. At x equal to -1, I can go on forever. Even at x equal to -1.5, this graph exists. But see these arrows? You're going to concentrate on that. See these arrows? That means this graph keeps going on and on and on and on forever and ever and ever. So even at, say, here I'll pull this way, at x equal to, let's say, -7, I'll take this. so you can help you see this. You gotta think beyond that area. This graph will keep going. Won't it eventually pass through this infinite long vertical line here? It sure will. So at x equal to -7, this graph exists. In fact, I can keep going on to -infinity. So this graph exists from -infinity all the way to +infinity. And I'll write that in interval notation. -infinity to +infinity. And we use these open parentheses when we write in interval notation. Even over here, just so you have this down, at x equal to 2, we can see this graph exists, but you got to think beyond that arrow. What about over here? Won't this graph, here I'll pull this out again, won't this graph eventually pass through this vertical line that goes on infinitely? It sure will. I think the key is the double arrows. If you see double arrows, that's a pretty good indication that your graph's domain, the function's domain, is all real numbers from -infinity to +infinity. But I can't say that's for all cases because there's going to be a hole in the middle or something. All right, now let's talk about the range. When we do the range, that describes the y values taken on by this graph, this function. All right? Now, we will do it like this one. We went from low to high. Low x, high x. What's the lowest y value taken on the graph? Well, rather than going like this from left to right like I was before, I'm going to take this and go like this. All right, we're going to think, what's the lowest y value? So how about right here? I see this double, that means this kept going, and this kept going. What's going to be the lowest y value taken on? -1, -2, -3, -4. This graph will keep going on and on and on downwards. So the lowest y is -infinity. I'll use the open parentheses again. We always use these open parentheses with the infinities. Now, the highest y value, it's not infinity. We can see, let me move this upward. All right, here we go, 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 here we go. There's the highest y value, we can see it. It's at y equal to 4. And I will put a 4 here and put a closed hard bracket because this function includes y equal to 4. It takes on y equal to 4, so it's included. We use these open parentheses with the infinities. Infinity is not really a real number, right? It's an expression. So now I'm going to go to the letter C. Let's go with the x-intercepts. I'm just going to put x-int. What are the x-intercepts? That's where the graph crosses the x-axis. We can see it's at -3 and at 1. And I'll write those as x, y coordinates. So at -3, 0 and at 1, 0. I can just put a comma between these. But at these 2 points, you have your x-intercepts. Yeah, it said x equal to -3 and x equal to 1, but I'll write them as coordinates. Letter D, how about the y-intercept? Notice there's only one y-intercept. This graph only crosses the y-axis at one value. You can see it's at y equal to 3. And again, I'll write it as an xy coordinate. So we have domain describing x, range describing the y values taken on the graph, x-intercepts and y-intercepts. Now we're going to talk about increasing and decreasing function. Where is this function increasing? And where is this function decreasing? Okay. So I'm going to put letter E. Where is this function? I'm just going to put INC. Where is this function increasing? I'm going to put a person on here. And this person moves from left to right along this curve, almost like it's a roller coaster. All right, here they go. Do you notice they're going up? So they're actually increasing. They're increasing. When do they stop increasing? Right there. So I'm going to put a wall where this person stopped increasing or going up. I'm just going to put this vertical wall here. All right. This is the location where the person stopped increasing. It's at x equal to -1. So when I describe this, increase and decrease in intervals, you must use x values. You must use x values. So what is the lowest x value and what's the highest x value for where this graph was increasing? The lowest x, remember this graph went on forever and ever this way, so it would be that lowest x way over here, -infinity. When did this graph stop increasing? At x equal to -1. So where's this graph decreasing? All right, letter F. where's this function decreasing? That's where the person started going down. We describe graphs from left to right. Graph started decreasing at x equal to -1. I'll use a red marker again. Graph started decreasing at -1. When did it stop decreasing? Well, it kept decreasing forever beyond x equal to -1. So what's the x value over here? If this was negative infinity, this is x equal to positive infinity, correct? So we always describe from lowest to highest, lowest to highest. Low x, high x, low x, high x. And you always use open parentheses when describing increasing and decreasing functions. Now, last thing. Let's just evaluate a couple points. We're going to evaluate a couple points. Hey, one more note about those increasing and decreasing functions. When we're describing them, you can actually think about drawing a tangent line. And whenever the tangent line is going up, that's where the graph is increasing, And we draw a tangent line to the curve, and it's going down from left to right, that's where the graph is decreasing. That helps too. Because if you ever take calculus, you'll talk about tangent lines. So lastly, let's evaluate a couple points. So we did A, B, C, D. We did E, F. Let's talk about G. Let's evaluate F of, let's say, -2. This is quite simple. When you see this written, F of -2, you just got to report. Write down the y value at x equal to -2 on the graph. So at x equal to -2, we look, there's x equal to -2, x-axis, right? The corresponding y value is y equal to 3. So it's that simple. X equal to -2, y is a 3. Let's do another one. How about it? F of 0. So at x equal to 0, tell me the y value on the graph. All right, well here's x equal to 0, but what's the corresponding y value on that blue graph? It's right there. It's at y equal to 3. And lastly, that's fine. F of, let's do f of -3. What is f of -3? At x equal to -3, which is right there, what's the y value? And we can see it's the y value 0. And that's it.